Today's notes are going to cover the polygon angle sum theorem. So a polygon is a closed plane figure having 3 or more straight sides. Closed plane figure having 3 or more straight sides. So we have two types of polygons. The first one is a convex polygon. It has no diagonal with points outside the polygon. So each of these diagonals between any of these vertices is always going to be on the inside. A concave has at least one diagonal with points outside. If I were to draw a diagonal from M to W, we can see that that is outside the polygon. So here are some examples. This is a polygon. It has 3 or more sides and it's closed. That means it's not open like this guy. This guy is not a polygon. And then having 3 or more straight sides, these sides are intersecting between endpoints on this one. So this is not a polygon either. So let's take a look at these 3 examples. We've got a closed plane figure with 3 or more sides. This one is concave because I could connect a diagonal from here to here. So this is a concave polygon. This one's not a polygon because it's got diagonals that intersect. And I'm sorry, not diagonals, but it has sides that intersect. And then the last one, this one is a convex. That means all of the diagonals between the vertices, they're always going to be on the inside. Okay, so an equilateral polygon has all sides congruent. An equiangular has all angles congruent. And a regular polygon is both equilateral and equiangular. All right, so let's take a look. Well, we know that a 3-sided figure is called a triangle. And, you know, just like this, 3 sides. The number of triangles is 1. The sum of the interior angles, we know that the 3 angles add to 180. And if it is one interior angle, if it was an equiangular, would be 60 degrees, if it was a regular polygon. Okay, if you have 4 sides, of course, you have a quadrilateral. Okay, and, you know, a 4-sided figure, something like this. Now, how many triangles could we make in this guy? Well, if I connected the diagonals, I could make 2 separate triangles. I would have one here and then one here. The sum of the interior angles. Okay, so if each of these triangles is 180 and I have 2 of them, well, that's just 180 times 2, or 360. And one interior angle would be 90 degrees on a regular figure. The next up, 5 sides is a pentagon. All right, so now let's draw a pentagon. That looks like a little house. Okay, so how many triangles could we make that don't overlap? Okay, so let's see, from the top vertice to this bottom corner, that would be 1. Top vertice to this bottom vertice, that would be 2. And this guy on the side would make 3. So I would have 3 triangles. Okay, so well, that's 180 times 3, which is 540. And if I were to divide that by the 5 angles, that would give me 180 degrees. I'm sorry, 108 degrees for each angle. All right, next up, we have a hexagon. Okay, so let's see if I can draw a hexagon. 1, 2, 3, 4, 5, 6. That's a terrible hexagon. Let me try again. It needs to look more like a stop sign or something. There we go. I think that's close enough. All right, let's draw our triangles. So we'd have 1, 2, 3, 4. 1, 2, 3, 4. So we could fit 4 triangles that don't overlap. So 180 times 4 is 720. And if I divide that by the 6 angles, each angle would be 120 degrees. Oh man, I gotta draw an octagon next. All right, 1, 2, 3, 4, 5, 6, 7, 8. Okay, that wasn't too terrible. Okay, let's see. 1, 2, 3, 4, 5. Woo, 6. I got 6 because I had 5 diagonals. Okay, so that gives me 6 triangles in between. 180 times 6 is going to be 1080. And if I divide that by 6, I'm going to have 135 for each of the angles. Okay, this one's called a nonagon, a 9-figured, a 9-sided polygon. All right, so luckily I don't have to draw this one, but I am going to connect the vertices. 1, 2, 3, 4, 5, 6. I'm going to have 7 triangles in there. So I'm not going to try to squeeze those numbers in there. But 180 times 7, and that gives me 1260. Divide that by the angles, 9 angles, and that gives me 140. Okay, a 10-sided is a decagon. And again, I don't have to draw it, thankfully. 1, 2, 3, 4, 5, 6, 7. Whoops, did I do that right? I didn't. I'm going to have to try again. That's better. 1, 2, 3, 4, 5, 6, 7. That gives me 8 triangles. 1, 2, 3, 4, 5, 6, 7, 8. That's 1440, and if I divide it by the 10 sides, each of those is 144 degrees. All right, and last up, a dodecagon. Dodecagon. This is a 12-sided figure, and let's just see if we recognize a pattern in these. If we had 10 sides, we had 8 triangles. 9 is 7, 8 is 6. Do we recognize that there is a difference of 2 every time? I don't know if I can draw the 10 in there, so you're just gonna have to trust me on that. That's 10. And so this is 180 times 10, which is 1800. Divide that by 12, and we get each of those angles is 150. So the sum of the interior angles, here's the formula for that. Okay, so we recognize that it was the triangle 180, and then the number of sides minus 2. We had 12 minus 2, 10 minus 2, 9 minus 2, okay? So it's 180 times n minus 2, the number of sides minus 2. And then to find one of those angles, wow, I wrote a 120. I meant to put 180, sorry. 180 n minus 2 divided by the number of sides. And that's what we did in each of these values over here. We divided by the number of sides to get this. Okay, so in a 15-gon, and after the dodecagon, we just call them by the number. So 15-gon, 16-gon, 22-gon, whatever. In this one, if we have a 15-gon and we want to find the sum of the measure of the angles, that would just be, well, 180 times 15 minus 2. And if we take that to Desmos, that's 180 times 13. I'm not going to do that in my head. 180 times 13. Whoa. Whoa. 2340. And a 22-gon. Whoa. Sorry. 180, 22 minus 2, that's 180 times 20. And that one I can do in my head because it's just 18 times 2 is 36 with 2 more zeros. And then the dodecagon, well, I already did that one, but it's just 12 minus 2. So that's 180 times 10, which is 1800. Now, if the sum of the measures of the angles is given, how many sides? Well, we're just using this formula working backwards. So 180 times n minus 2 is equal to 1980. If I divide both sides by 180, then 1980 divided by 180 is 11. And so this is n minus 2 is equal to 11. If I add 2, then we're talking about a 13 gone. All right, let's just skip to one more example. Let's do just number 3. So again, we just set up our formula. 180 n minus 2 is equal to 6120. First thing I would do is divide both sides by 180. 6120 divided by 180. That's 34. So this is n minus 2 is equal to 34. If I add 2, n is equal to 36. A regular polygon is given. What is the measure of one of the angles? Okay, so I'm not going to do the triangle. Let's do the 15 gone. All right, so if I want to know one of the angles, remember, we would have to divide that by n. So 180, n minus 2 divided by n. 180 n minus 2 divided by n. All right, so 180 times 13 divided by 15. Let's take that to Desmos. 180 times 13 divided by 15 is 156. And then let's try one more, the octagon. So that's 180, and of course I know an octagon is an 8-sided figure. So 180 times 8 minus 2 divided by 8. So 180 times 6 divided by 8 is 135. That is what one of those angles is. All right, just a few more examples. Number 7, this is, let's see, let's count the sides. We've got A to E, that's 1, 2, 3, 4. This is a pentagon, right? And we want to find what X is. So if I want to find the sum of all of these angles, I would need to use this formula here. 180 n minus 2. So what's 180 times 3? 180 times 3, I believe, is 540. Let me just double check. 180 times 3. Yep, 540. So I know that the sum of all these angles, if I added them all up, that would be 540. What I need to do now is just go ahead and add up each of these. X plus 91 plus 160 plus 100 plus 80 equal to 540. Okay, let's take these guys to Desmos and see what the sum of those are. So what was that? 91 plus 160 plus, and the order doesn't matter, 100 plus 80. So that's 431. Now, I already calculated that the sum of the interior angles is 540. So if I take 540 and I subtract the 431, I know that that remaining angle, oh, whoops. How did I get 463? How about 431? It's going to be 109. I must have hit the wrong numbers. So that last angle, this is going to be X plus 431 is equal to 540. And when I subtracted that, X was 109 degrees. And that was what this angle is. Okay, let's try this one more example. Let's do number 8. So let's see, we've got 1, 2, 3, 4, 5, 6. This is a 6-sided figure. So 180, 6 minus 2, so that's 180 times 4. And I believe that is 720. All right, so now let's add up each of these. Oh, and we have a 90 degree here. And then we'll subtract it from 720 to find that last angle. Okay, so we'll start with the 90 degree and then just go in a clockwise direction. So 124, 150, 93. Okay, back that up, 93, 130. All right, those angles add up to 587. And we said that the sum of a six-sided was a 720. So if I take away the 587, that's 133. And so our missing angle is 133. Whoops. And I just did that all on Desmos. All right, guys, I think that's going to be